In the last lecture we have learned about NSGA, non-dominated sorting genetic algorithm proposed by N. Srinivas and K. Dev, and we have discussed some limitations there. Addressing all those limitations, the same authors with some other more researchers, they have proposed another algorithm, the next version, the improved version of NSGA. It is called the NSGA-II algorithm. So, this algorithm is called elitist multi-objective genetic algorithm and abbreviated as NSGA-II, and the basic concept in the NSGA or rationale in the NSGA-II is basically so that it can be computationally much efficient, and then it gives better result compared to the NSGA. So, this is the idea about there in NSGA-II approach, and here are the contributors who developed this algorithm. The contributors are K. Dev, A. Pratap, S. Agarwal and Maria Vian. This algorithm NSGA was first time proposed, introduced in 1994, and around 8 years later this algorithm NSGA-II has been proposed by the same group of researchers in the same lab. So, this lab is basically the lab there in IIT Kanpur, okay, and this lab is famous as NSGA lab. Now, the work NSGA-II first time is published in IEEE Transactions on Evolutionary Computation, and the title of the paper was a fast and elitist multi-objective genetic algorithm NSGA-II. So, basic idea, they claim that it is fast and elitist. Now, we will see exactly how the time complexity have been owned here, and then how the concept of elitist has been enjoyed here or is applied here rather, and the algorithm it is there. As the algorithm is bit complex and lot of steps are there. So, we will discuss it in two sessions. In the first time we will discuss the basic concept or overview of the things, and it considers some unique approaches there. It is called the crowding sort. So, for the selection is concerned, we will discuss in the next slides. Now, let us start about the concept. It is there in this algorithm. Now, in order to understand, okay, we can recall that the NSGA basically consider the front, they basically calculate all non-domination front, it is called, and then once the front is calculated, then they assign fitness values to all the solution in a particular front. This basically the dummy fitness values, and then sharing the fitness value by means of niche count. However, the procedure that it follows is totally different. This is because finding the non-domination front itself is a computationally very much expensive. We have discussed about that. The complexity of finding the non-domination front is in the order of m n square, where m is the number of objective and n is the population size, and we will discuss, we will see that how it also consider the finding non-domination front, but in a different way. We will discuss about this procedure. Let us first consider the different notation that it follows to discuss about it. So, like the NSGA procedure, we consider the P is basically input solution set, that means set of all solution belongs to a current population, and we denote xi and xj are any two solutions in the set of solutions, and here P dash is the set of solutions on non-dominated front. So, P dash be the any solution it is there. Now, so it is the okay, these are the terminology that we will follow, and then the procedure, the approaches is like this. So, here every solution from the current population set, that is P, is checked with a partially filled population P dash, which is initially empty. So, the idea is that given a set of solution P, we have to first find a non-dominated front P dash. So, it is basically idea. So, how the from the set of solution P we can find P dash. So, basic idea is that initially P dash is empty, and we can randomly choose okay. So, basically initially P dash is empty, and then we have to fill the P dash with some solutions. They are basically the solutions are in the domination front. So, P dash basically say contains all the solutions belongs to the domination front at any instant. Now, to start with this, that means filling the P dash from the P, what basically idea is that we have to randomly choose one solution xi which is in the P. 1 by 1 is basically, that means all the solutions should be checked 1 by 1 which is there in the P. Now, here, so compared with, then this xi is compared with all members of the set P dash. So, initially the P dash is empty, this means that xi should be there in the P dash initially, or in other words, suppose P dash is not empty, then it basically check this one. If xi dominates any member of P dash, then that solution is removed from the P dash, because the P dash should contains all solution which is not dominated by any other solution. That is why P dash should be a non-domination front. So, it is removed there, and the same procedure is repeated for all other solutions 1 by 1, and then P dash will be gradually filled, and then P dash contains all the solution in the non-domination front. So, this is the idea about this one. So, here again repeated is, if solution xi is dominated by any member of P dash, the solution xi is ignored. So, this solution need not to be considered in the P dash. On the other hand, if solution xi is not dominated by any member of P dash, it is included into the P dash, because xi is therefore the solution to be in the non-dominated form. So, this way the P dash grows when we checked all the solution xi belongs to P, the current solution 1 by 1, and when all the solutions of P are checked, then the remaining members of P dash constitute the solution on non-dominated front. Now, you can understand this basically the technique in the last slide and this slide includes, and this basically the clever idea about the previous approach. So, this solution is better, this solution is basically find the non-domination front P dash. Once the P dash one first front is obtained, you will remove all the solution P from the P dash and repeat the same procedure finding the next front and so on so on. So, this method is therefore different than the non-dominated sorting procedure in NSGA, and it is more faster than the procedure that is there in NSGA. So, this way it is a fast method of finding non-dominated sorting front. Now, so the idea it is like this. So, it is basically it will these are the steps that we can follow and more precise steps that is there in the calculation of non-dominated front there, and we can observe that a detailed calculation can let you that the complexity of this procedure is order of mn square, and in worst case it is order of mn cube, although the same complexity here, but still it gives the better what is called the time than the previous one. So, this way this is the improvement over the NSGA so far the non-dominated sorting front calculation is concerned. Now, we will discuss about the basic approaches of NSGA-II. First, the thing is that how to find the non-dominated sorting front. Now, okay, we have learned about that complexity of the two algorithms are same. So, anyway, both NSGA and NSGA-II needs to calculate all the front it is there. So, whether the new method that we have discussed just now can be followed, or the method that is there in NSGA also can be followed in order to calculate the non-domination front. Anyway, so non-domination front calculation is there in both the algorithm NSGA and NSGA-II, either say non-dominant sorting procedure or the revised procedure that is there in NSGA-II algorithm. Now, let us see what are the basic steps that it is followed in NSGA-II algorithm after the calculation of non-dominated sorting front is known to us. So, here is the procedure that I can give in a stepwise manner. So, let P be the current population, that means the initial the current solution or current generation. Then here the idea is that it basically from the current population P it generates offspring population Q, right, and so this is basically reproduction. That means considering the P and whatever the method that is known to us in the simple genetic algorithm, that means how to create the mating pool, the crossover and mutation, if we follow, then from the set P we can derive another set Q. Basically Q is the next generation like. So, basically from the current generation P we shall be able to generate the new solution sets Q based on the reproduction techniques, the usual. Now, once the P and Q are known, what the technique in NSGA-II is that we combine all the solutions both from P and Q together a solution sets. That means if P is the initial solution and then Q is the next solutions, then the combining the two solutions gives a solution size or a population size, let it be R, is the size of 2n. So, R is basically all the solution those are there P and then Q. So, as P is size of n, Q is size of n, so the size of R is equals to n. So, basically we will develop a large population set of size 2n, and then the on this solution set R we have to apply the non-dominated sorting procedure that we have discussed, so that all the fronts can be calculated. So, from R we will calculate all fronts. So, F1, F2 dot F k number of fronts say. So, k number of fronts that can be calculated using the non-dominated sorting procedure like. Now, so after the non-domination sorting is done, the new population P is obtained. Now, so this is the current population. From this current population the new population P will be obtained by filling the non-dominated front one by one until the P dash is less than P. So, here basically the idea is that, so say suppose F1, F2 then dot Fk are the different front. So, one P, so from the P dash, okay, so from the P the next P dash has to be obtained. Okay, so it is basically okay, we are in the process of getting the next population set P from the current population P. So, basically we will select F1 if we see that size of the next population is less than the population size, that is basically n. So, if we select F1, F2 and we will go on selecting until this condition is satisfied, and you can say the last front is the one important front. Basically this front, if we include into the current population the limit, that is the size of the population will exceeds. So, that last front is the one important front that needs to be taken into care and the special treatment to be applied. Now, we will see exactly what is the special treatment that can be applied to the last front, and here is basically the concept of some selection, okay, and that selection is a vital there in NSGA-II and is basically the main reason behind the success of this algorithm. Now, here so idea it is there. So, since the total population of size 2n and we have obtained the many fronts, then all fronts may not be accommodated in the fronts available in P dash. So, all fronts which could not be accommodated are simply rejected. Now, here again I can say this one, say F1, F2 dot Fk dot Fm. So, these are the all fronts that can be obtained from R. So, given R non-dominated sorting procedure, we will calculate all front. Now, up to which the Fk front can be filled so to the current population P dash like, okay, and so that it is less than the size of P, that is the population size. Okay. Now, so the remaining fronts, those are there, they can be simply ignored. So, they simply rejected. So, this is the procedure it is there, because they are not good for creating the mating pool or next population generation. Now, here the idea again, instead of arbitrarily discarding some members from the last front, the solutions which will make the diversity of the selected solutions at the highest are should be chosen. So, this is the one important criteria or rationale that, so the last front contains some solutions which basically then the maximum size of the population, then how to select the solution so that it exactly the same as the population size. So, basic idea is that from the last front we have to select that solution which has the very good so far the population diversity is concerned. Now, in order to select those solutions which is there in the last front, the NSGA-II procedure consider one method, it is called the crowding distance method, and this crowding distance is basically is idea about that how to select a winner out of the solutions those are there in the last front. And so this is the basic idea about here in this technique. The crowding distance we will discuss in details in the next slide. So, crowding distance is very important concept there, we will discuss these things in the next slides. Now, let us first proceed about the other concept it is there. And okay, we can summarize the discussion about the basic steps that is there in NSGA-II. So, it is basically NSGA-II technique, right. Now, here okay, we can summarize the thing that we have discussed here. So, these are the current solution in the current generation. So, P, and from the P we produce the Q, the next solutions for the next generation. So, P and use the reproduction method, so that from P the Q can be generated. So, all the solutions together it is called the R, and then the size of R equals to 2 to the 2 n, where n is the size of P and n is the size of Q. So, this basically the solution sets that needs to be considered for the NSGA-II approaches. So, this is the first step, that means the current solution P and then reproduction after reproduced solution Q are combined together. Now, from this current solution P and Q, or that are the merged solution R, we have to find the non-dominated front from here. So, suppose these are the front F1, F2 dot 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 dot, say Fm number of fronts are there. So, there the separate fronts has been calculated, that means this is the front 1 first, front 2 second, front 3 third, and so on. So, this can be obtained following the non-dominated sorting procedure. Now, next is basically selection. Now, this selection first is that this F1 front should be selected if we see that after adding this one the size of the population will not exceed the quota or limit, that is the n. So, it is basically P dash. So, we have to go on. So, if F1 will be added into this P dash, if we see that size of the P dash is less than n. So, this is selected. Similarly, F2 can be added here if we see that the size of the P dash is less than n. So, this way we have to select all this one. Now, after selecting so many things, suppose at this page one font is like this, which is the next font to be considered, but if we add this font here, then the size of the P dash will be greater than n. This means all the solutions which is there cannot be arbitrarily selected into here, right. So, this is the idea about then this procedure says that then we have to play one tournament among all the solutions which belongs to there, and based on the tournament selection we will select the solutions here to fill the population size P dash is equals to n. Now, this tournament selection is basically based on one technique, it is called the crowding distance technique, and all the solutions. So, from there all the solutions which are the winner to be selected here, and for the rest of the solutions are simply to be rejected. So, this way from the current population P we will be able to obtain the selected population, and this is basically the mating pool that needs to be considered for the next generation population. So, from this mating pool we will be able to consider the Q, the next generation population, and then same procedure will be repeated again and again until the termination criteria is satisfied. So, this is the idea that the NSGA techniques follows here, but in order to understand the NSGA technique again, that means here is this procedure is the most important procedure, that means how the tournament selection based on the crowding distance can be obtained. So, this is the important thing that is there, and so basic idea again. So, whatever the step that we have discussed earlier, it can be little bit expressed in a formal way. Combine parent P and then offspring solution Q to produce the resultant solution R, perform a non-dominated sorting to R and identify the different front, this is called the non-dominated front Fi like 1 to 2 etc. Now, set new population P dash initially which is empty, and then we have to follow this one until we have to select the front. Now, P dash plus front 1 should be added, so that it is less than n, and we stop this selection or adding when we say that it greater than n. So, for the greater than n we have to consider the method, that means a selection method, that is called the based on the crowding selection, it is called the crowded tournament selection procedure. Now, the crowded tournament selection procedure follows one method, it is called the crowding sort for all the solutions which belongs to Fi, and then based on this crowding sort it will consider n minus p dash solution, because these are the solution that needs to be filled up, and that can be based on the crowded tournament selection, and this way the next generation can be obtained and then next offspring generation can be obtained. So, this is the idea about it. Now, learning the NSGA-II for this method, that means how to select the solutions from the last dominated front in order to make the solution size same as the population size, and then this procedure needs the discussion of the crowding sort techniques. So, the crowding sort techniques, so we will discuss about the crowding sort techniques in the okay. So, we will discuss the crowding sort techniques in the next lectures. Thank you.